All right, so this is taking some old geometry skills and smushing it in together with our polynomials. Ew, my geometry's in your algebra. Your algebra's in my geometry. Ew. That's okay. Because all we're asked to do is to find the volume. So, how do we find the volume of a box like this? I don't remember how I find the volume of a rectangle or a rectangular prism. Volume equals, how do we find a generally for a rectangle? Or how do we find the area of a rectangle? So I just wanted to find the area of some rectangle like this. And this was, I don't know, maybe length, and this one was maybe width. How do we find the area? Length times width. For volume, it's length times width. Then we just got to take our new dimension here and multiply that guy on. Times height. This imaginary one is height. I'm good at drawing, y'all. Look at my beautiful rectangle. Ah, it's so pretty. So volume is just length times width times height. So to find the volume of this box, we're going to take our length, 8x minus 3, times our width, 3x plus 4, times x. This is our length and our width and our height. These are just labels. They look like they're exponents, but they're not. Oop. I'm going to put them in the middle then. And then what we're going to do to find the polynomial that is the volume of this box is we're going to multiply this out. It's been a minute since we did polynomial multiplication, so I want us to practice it. Our volume is, and we're going to take our 8x times our 3x to get 24x squared. Going to take our 8x times 4, and when in doubt, feel free to use the calculators. We get 32x. We're going to take our minus 3x, or minus 3 times 3x, giving us minus 9x. That orange and that red is very similar. Our minus 3 times our minus 4, giving us minus 12. And then we're still living inside parentheses, and this x is still hanging out over here. From here, we're going to combine some like terms. Our volume is 24x squared. We have 32 minus 9 to get 23x minus 12 all times x. So I'm just going to write it inside the box just because it's a big space with lots of space. Our volume, the equation for our volume, we are going to distribute everybody to the x. Multiply that x through. So our volume is 24x cubed plus 23x squared minus 12x. And that's our final answer. So it's using our polynomial multiplication in a context. Questions on what we did here? I know it's early on the last week before a week-long break, and we're approaching the end. But it's one of those things we hadn't done a problem like it, and I wanted to make sure that we'd seen one. Okay, so what we're doing today is not technically new. We're going to use what we did on Friday and smash it together with some backlinks. We are asked to find all the solutions, all the roots, all the zeros. And it says you can use long or synthetic division. It does not matter. Synthetic division is shorter and faster. The way I tend to lean, because it's short, it's fast, it's simple. We love it. But if you're not comfortable with synthetic division, you don't have to use it. You can do long division. I'm going to go ahead and do synthetic division whenever I have a root that's a whole number. So what is our root here? What is the solution for what we're dividing by here? When does x minus 2 equal 0? When x is what? Positive 2. So whenever this is a whole number, I'm going to go with synthetic division. It will still work with fractions. We tend to just get a little about them. But so that's just kind of my general rule of thumb, is that if what I'm dividing by is a whole number, I will use synthetic division. Anything else, I'll use long division. But you get to make the choice for you. So since our solution here is a whole number, I'm going to use synthetic division, which means I need to grab all my coefficients from this polynomial. So I'm going to build my little structure here. I'm going to build my little structure with a little bit less wasted space. There we go. We know we've got our root that goes over here, which was a 2. And then we're going to take our coefficients. The coefficient in front of my x cubed is a 1. The coefficient in front of my x squared is minus 4. The coefficient in front of my x is minus 11. And my last one is a positive 30. Questions on the setup part? Okay, because now we're going to work it through. First term always drops. What goes here? Do we remember? 2. We take this 1 times this 2, and it goes here. So we have 2. And then we add. Negative 4 plus 2 gives us negative 2. What's going to go here? Negative what? Negative 4. Sorry, I just couldn't hear. Negative 4. Then again, we add. Negative 11 plus negative 4 gives us negative 15. Negative 15 times 2 gives us negative 30. And when we add those, we get 0. This is our remainder. Which means our leftovers, this is our constant term, this is our x's, and this is our x squared. So we can write this as the polynomial x squared minus 2x minus 15. And if all we were asked to do was divide, we would stop right there. But they've asked us to see if we can find all the roots, all the solutions. all the zeros of the polynomial. So we're going to look at this guy and remember some factoring. We're going to try and solve this guy. So let's see if this one will factor. Let me get another color here. So if we try and factor this, remember this is my A, this is my B, and this is my C. A times C at the top. We get 1 times negative 15, which is negative 15. I got it, Daryl. And our B goes at the bottom, which is negative 2. Hello.
Good morning. Can I talk to you?
This is in the middle of class right now. Okay. Super important?
What'd you say?
This is super important because we're in the middle of class right now. And we got a test this week.
I mean, it's gonna be real quick, like.
Amari. There you are. They want to talk to you. All right, do we have a pair of numbers that multiplies to make negative 15 and adds to make negative 2? Is there a pair of numbers that multiplies to make 15 and adds to make negative 2? Negative 5 and 3. Negative 5 and positive 3. So we could write our quadratic as our x squared minus 5x plus 3x minus 15, if that helps you. Or you can go into your box. There's a few different ways to approach this when we're factoring here. With our x squared minus 5x plus 3x minus 15. I don't care which direction you go to factor it. I don't care. I don't care. I don't care. Okay, there's benefits to all the different ways and there's holdbacks of all the different ways. The box takes up space. It's its downfall. So when we pull our factors in columns and rows, we have x minus 5 and x plus 3. So our factored form of this quadratic is x minus 5 and x plus 3. What are my solutions for this part of my polynomial? What are the roots if these are the factors? X equals 5. It was whispered, but I heard it. X equals 5. And x equals negative 3. Okay, so we didn't add anything new. We're just smushing it together with some old stuff. And you don't have to do this every time. If it tells you to find all the roots, that's when we do it. So this is find all the roots, is these guys. I want the rest of them. I want you to find your solutions, which more often than not is going to be something factored. You may want the quadratic formula if that's your kind of deal, but okay, so that's all we're adding today. Like, that's it. We're going to do another one. We're going to find all the roots of the polynomial given this information. I know that x minus 1 is a root. Or I know that x minus 1 is a factor, excuse me. Wrong word. If x minus 1 is a factor, what is one of my solutions? X equals what? 1. It's whenever x minus 1 equals 0. So I'm going to set up my synthetic division. If you love long division, absolutely fine. You can long division to your heart's content. But long division is long, and synthetic division is so fast. So we're going to put this together. I have my 1 out here. And then inside goes the coefficients for all of these terms. So I have my 1x cubed, my minus 1x squared, my minus 25, and my plus 25. Look at me. So we're setting up our next one. And we're ready to process it through. We're going to go ahead and drop our first term. 1 times 1 is 1. Add them together and we get 0. 0 times 1 is 0. Plus negative 25 is negative 25. 1 times negative 25 is negative 25. And our remainder is 0. So when you work it across, you should have something like this. So we're going to write this out as our polynomial. This guy is our constant. This is the coefficient for my just x's. This is my coefficient for my x squareds. So we have our 1x squared. I have 0 x's, so we don't have to write it down because 0 times anything is 0. Minus 25. And we're asked to factor this to find our rest of our solutions. That's our next step, is we're going to factor this out. Does anyone see a shortcut we could take for the factoring process here? Because this guy's a perfect square. And this guy's a perfect square. And we are subtracting 2 perfect squares. So this is, in fact, a difference of perfect squares. And if you remember that pattern, you do not have to X, you do not have to box, you are ready to rock and roll. If you don't remember that, you still absolutely can. Let me show you how that goes. My A is 1. This guy's always my A term. This is my B, and this is my C. So my A times C is actually 1 times negative 25. And my B is 0. What's a pair of numbers that multiplies to make negative 25 and adds to make 0? 5 and negative 5. So you can put this through your box. And we're going to wind up with x plus, oh, tiny, tiny x. Let's try that again. X plus 5 and x minus 5. So what are my roots? X equals negative 5 and x equals positive 5. Okay, how we feeling on our find all factors situation? Let's do do one that is a little bit harder. So it's written like a fraction. We've got 2x cubed minus 3x squared minus 8x plus 12 divided by 2x minus 3. It's just another way to write division. I will zoom it in so that you guys can see, because I see a lot of squinting and zooming. It is not any different than when it has the division symbol between them. It still just means divide. And since it has a subtraction in the denominator, we can't use the way we cut it into separate fractions. It just doesn't work that way. You absolutely can do synthetic division. However, this root is going to be a fraction, and you run the risk of fractions throughout. But you can do it. However, my instinct, whenever I have something that gives me a fraction as a root, or whenever I have an a value, basically, whenever I have a number in front of my x, I'm going to do it with long division, just so we can remember how to do that. So I'm going to set this up old school with my 2x cubed. Zoom this back out. Minus 3x squared minus 8x plus 12. And we're dividing this by 2x minus 3. So when we are dividing by something that has a fractional root, I recommend long division. It will still work to do synthetic division. You're just going to wind up with fractiony goodness the whole way across. So what we do is we take our first term and we set up our little baby division. I want to know what 2x cubed divided by 2x is. What is 2x cubed divided by 2x? Super close. Just the x squared, because the 2's actually cancel out. So we are going to put an x squared on the top. We take that x squared times the whole factor and write it under here. So 2x times x squared gives us 2x cubed. And minus 3 times x squared gives us minus 3x squared. And then we're going to subtract the whole row. Two x cubed minus 2x cubed gives us 0x cubed, is what we were hoping for. And then negative 3x squared minus negative 3x squared. How many x squareds do we have left? What's negative 3? Ooh, not the laser pointer. Negative 3 minus negative 3. 0. My x squareds canceled out too. So then we're just going to drop my next two pieces. Minus 8x plus 12. These guys are just going to fall. These ones canceled out, and that's okay. Because then we get to do this cycle again with my minus 8x and my 2x. So if we have minus 8x divided by 2x, what do we have left over? Super close. Minus 4. What happens to the x's? They cancel. So we just have minus 4. As our next term. So then we're taking our minus 4 times this whole factor, and it's going to go under here. Minus 4 times 2x gives us minus 8x. And minus 4 times minus 3 becomes plus 12. And we are subtracting the whole row. Minus 8x minus negative 8x gives us 0 x's. That's the whole point. If we don't get a 0 there, something went wrong. 12 minus 12 is also 0. And that would be our remainder. On these ones that say find all of the roots, you should always have a 0 or a 0 remainder. Every single time. So what I have now is x squared minus 4, and we are still trying to find all of the roots. So I need to find the roots of x squared minus 4. Oh snap, it's another difference of squares. Told you that pattern would come up a bunch. How do we write this as a factored form equation? What's our special pattern that we can do with this? I can hop straight into my factors. If you remember, it's whatever this first term was, unsquared. And whatever this second term is, unsquared. What is the square root of 4? 2. One of these factors gets a plus. One of these factors gets a minus. So what are our roots here? Or our solutions? Yeah, x is negative 2 and x is 2. Okay, so finding all solutions, it's not adding anything new. It's doing the same long division we did last week or the same synthetic division we did last week and factoring your quotient, whatever guy's on the top. Okay, so we do have a test coming up on Thursday. My necklace is backwards. There we go. So we have a test coming up on Thursday of this week. I will have the review for you guys tomorrow. If you want it today, swing back by about 5th period and I'll have them for you. But I just didn't get the copies made on Friday. So we have a test on Thursday. And we will... Tomorrow... I will have the review for you tomorrow. I just don't have it right now. So tomorrow and Wednesday are going to be work on review days. Tomorrow will be our independent work day, and Thursday will be the one where we go through things together. Nope. Wednesday will be the day we work through things together. Thursday's the test. I keep trying to make it be Friday, but no one wants to test the day before. Nobody wants that. Okay? So, but then again, I have also heard that all of your teachers are saying that, so now Thursday's just become the day of everybody having a test. Sorry. We're all trying to be nice, I promise. Okay? But that's kind of the vibe. I will get the review guides printed out. It's just one of those things that fell off my plate on Friday. Sorry. But, so if you still have your 4-4 homework, now's an excellent time to finish up that. Oh, snap.